Okay, so this is part of the service manual for the HP 5342A, as you can see here. Now, the up to 500 MHz input doesn't work, but above 500 MHz does, which helps narrow it down a bit because they share a lot of circuitry. Right. So, first part is direct count section. Now, this is A3. Which is direct count amplifier assembly and the A13 counter assembly, right? So frequencies less than 500 MHz may be measured directly by the direct counts input. Now that's the key there, okay? So it measures it and then subs it through to the MPU. Let's scroll down to the block diagram, which unfortunately is not great. Try to make it a bit better for you. All right. There we go. So 0 to 500 MHz comes through direct gate circuit here. There's also a switch here, which also could be a problem. But basically, this then outputs direct to the says MPX here, right? And that is shared between the 500 MHz input and the 18 GHz input. The same device, same section is passed through. So it means that it's likely that the problem is actually on this assembly here, the A3 assembly, right, under the direct count section. So it's most likely that's the problem. I haven't checked the actual RF feed through, so I haven't actually gone right from the input jack, followed it through to make sure it's not a connection that's bad or something like that. I haven't done that yet, but I'm leaning towards this board being dodgy first. That's the most likely problem. Okay, so I shall. Okay, so here's the circuit diagram section. So here's the 500 MHz input. All this upper bit here is the 18 GHz input. So I'm ignoring all this for now. And I'll bring this over. Follow the input line across. Comes up into this assembly here, which is the keyboard assembly, as we know about, which has got the switch on it for the 50 ohm 1 mega ohm input. So those come through these two paths here. There's 50 ohm there, 1 mega ohm there. That's a bit bigger, right? Which then goes into the A3 direct amplifier assembly. So you've got a limiter on your 50 ohm and nothing, straight into an amp here. It's got an AGC on it as well to level control. So there's a test point here, TP1, which I'll probably have to look at, because obviously that signal should be at this point if all this is working. Now the 50 ohms has got a fuse in series in there, but I tried the input on 50 ohm and 1 mega ohm and it didn't work either way. Right? So this then has this gate here, which is controlled by this signal line, and it comes up, goes through these dividers, and then goes up into this main counter assembly. Now all these lines here, those are from the 18 GHz section. So that's obviously the controller, and this one here is the 18 GHz section coming in. Alright, let's go up slightly higher. All this mixing and stuff and going on there, the IFs and what have you. So that comes into the same device. So both frequency inputs go in to this section. So means this section here is probably fine. It's likely to be the A3 board, most likely. So that's where I'm going to be looking to start with. Being there's a test point just here, is probably what I should be looking at there. But I'll pull this board out and check capacitors, and it's likely just to be a bad cap. Alright, so that's probably what I'm going to start with. I'll follow through the RF chain first. I'll follow the RF through, make sure it comes out to here and gets to there, and I'll see if I can get anything at TP1. But it looks like a fairly simple board. I'll try and find the actual diagram for that board itself. It'll be in here. I just haven't got that far yet. Right, so I've just got this set up now. I've got the Marconi here running 10 MHz signal in, just for the sake of 10 MHz, and running a 200 millivolt signal in. And all I need to do is just check that these two coax here, one's the 1 mega ohm, this one here, and that's the 50 ohm there. So I just need to make sure that those are correct. Alright, so but then that's the card section right there. So if it's getting to there, then the problem is likely to be on the card and I have to flip it back over and power it up and do some testing on the card itself. So let's do 1 mega ohm first because I'm closest to it. And I have nothing there. Oh no, here we go. Must just be insulation there. Okay, so yep, okay, so 1 mega ohm side is there. Voltage looks about right. There's a bit of a drop as you expect with the circuitry up here, but it's not much. 50 ohm, yep, that's there as well. So they're the correct way around and the signal's passing through and getting to that card. Okay, so that's the first thing I need to do, identify whether even get into that first card. So I'm happy with that bit. So now I need to power this up. Get the cable. And do some testing on that card. I think I can get to the test points on there. I've pulled that card out already and had a little look at it. I couldn't see anything obviously wrong with it. So that part should be fairly straightforward, hopefully. Alright, so I don't know what I'm expecting to see on this card. So the card is this one just here. Let's just stick a different probe tip on here. Don't want to short anything out. Clip that on now. There's a test point just there, which is test point 1, and there's another test point further down, which is test point 2. Test point 2 is the input into the Schmidt trigger. So, interesting, I've got some display artifacts. That's interesting. Why do I have display artifacts? Do I push the button? This is interesting. It's flashing a bunch of different indicators. Something's different. Didn't see that before. It's got some artifacts on display. I might just repower it. I did test the power supply off camera as well, and it seemed to be outputting roughly about right. This is looking different. I'm not sure why. Let's just look on to the output the Schmidt trigger first. Nothing there. Input the Schmidt trigger. Nothing apparently there. Okay, I'm seeing something at that position. That's on 1 mega ohm. Let's increase the output level. No, it didn't really change anything. So I'm seeing something there. I don't know whether it's what I'm supposed to be seeing. Don't know. But now I'm concerned of getting some artifacts on the screen. I don't think this is right. Let's increase this frequency. Wasn't doing this before. I'm going to show you this. Now, previously I did a test at 500 megahertz and it was all fine. Now I'm getting this, which is interesting because before it was alright. So if I repower this, see, that's not right. Got these flashing as well. this is interesting because it wasn't doing that before. Before that was okay. If I dislodged something somewhere, maybe. There's a connector there for the display. It's going to give that a wiggle around. Maybe I've disturbed it or something. Make sure everything else looks okay. Oh, let's try again. I don't know why these are flashing. Maybe it means something? I don't know. This is interesting. So I guess it didn't do this before. It's not the best camera angle, unfortunately. Still don't have any input, but so it's actually deteriorated since I tried it yesterday. Yesterday it actually displayed a frequency. No, it doesn't. Alright. There goes that theory then. May not be just that one card which has got a problem, it might be multiple issues. Well, let's kill the power. I'm going to have to do some more digging. Alright, sorry about the lighting, it's a bit bad, but okay, as you can see I've got the display back. Now this is on the 18 GHz input. I wiggled a card around and it came right, so I wiggled this card here. Oh, try and get a camera. This one here, I wiggled that one around and it came back. So it must just be dirty connections on these boards. Or it could be cracked traces or something on the bottom, or bad solder joints, who knows, but they got that back. And then I thought, okay, well if that works on that, I'll stick it back on the 500 MHz input. And now, at 50 ohm range, I'm seeing a frequency. And that was by wiggling that card around again, that A3 card here. Wiggled that one around and then that came back. 1 mega ohm input doesn't work though. There's still nothing there. So there's still an issue. But I've at least got it working on 50 ohms. So I think all I should do is pull every single card out, clean up all the connections, inspect for any dodgy joints, and go from there. But the fact it's now actually reading that signal on there is a good thing. Now if I go to 10 MHz, should still read that, okay? Yep. Alright, so and 1 mega ohm input. 1 mega ohm's reading. Interesting. And that's a 0.3 volt input, or 300 millivolt input. So let's go back to, let's go 400 megahertz. It's not reading the high frequency on the 1 mega ohm input, but on the 50 ohm it is. Okay, let's just do 100 kilohertz. Should be able to read that. Yep. 10 kilohertz. Yeah. Okay, so 50 ohms reading fine all the way up to 500 megahertz now, and that's reading at a lower frequency. Let's try different frequencies to see what it drops out at. It's 100 megahertz there. 50 megahertz. No, can't be 50 megahertz. 30. Yes, it's reading 30. Okay, interesting. Oh, that's kilohertz, not megahertz. 40 megahertz. That's there. 45. Yes. 48. Barely. Okay, let's do 55. Gone. If I increase the RF level to 0.5 volt, now I can read it. Okay, so it seems like it might be a sensitivity issue on the higher frequencies, but it is working now, whereas before it wasn't. I mean, I did try putting in 0.8 volts when I was testing this before. So okay, let's go 500 megahertz again, which should be at a sense. Oh, get the right thing. 500 megahertz. This is at 800 millivolts. Cannot see it. No. 300. No. 200. So it does have an issue. But only on the 1 mega ohm section. So that's rather interesting, isn't it? The input level to that card is okay, so it must be something to do with that sensing. So I was trying to find out the point where it will actually start working again. That's 60 megahertz there, okay, 70. Seven is dropping off, so anything above 70 megahertz isn't working properly. So that is very interesting, but at least I've actually made some progress now. I've got the thing to partially work. So let's disconnect all this stuff. So I need to start pulling cards and cleaning all the connections up, and we'll see how we go from there. As I pull them out, I'll check all the capacitances as well. I mean, I've got my meter here ready to go, so I'll pull cards out and check the caps as well, see if I find any bad ones. I know that one has got a bunch of tantalums on it. Which one was it? I did see them down there. I think it might have been that one. Might have been that one actually. I don't know. Anyway, so made some progress. Wiggling the card around has got it partially working, so that looks promising at least. Alright, so I've been playing around with this thing, and I've taken every card out, cleaned up all the connections on the card edges, plugged them all back in again, and it's been a lot better since then. It's played up a lot, much less. It seems to be basically working okay now. The sensitivity on the 1 mega ohm input on the 0 to 500 megahertz does drop off over sort of after about 40-50 megahertz. It drops off sensitivity, but then I checked it against my other one of these, my first one, and that does the same thing, but not quite to the same degree. It doesn't suffer from it quite as badly. So this is less sensitive, but the frequency range is covered by the other input anyway, so it can still do the full range, and it's just you have to use a 50 ohm input instead of the 1 mega ohm input. But it seems to be basically behaving now. So what I'm going to do is take this front panel off and see if I can replace this knob which is on there. Well, that pot which is broken. So I've pulled these wires off already. I've got to remove this solid coax here. Either I take it off here or I take it off here, and taking it from there is a bit easier, I think. So I'm going to give a tool to do that with. Right, I'm actually waiting for some more tools to arrive. I've purchased a bunch of stuff recently, got mini spanners and stuff like that, and what have you. So I expect to be having a set of tools for in here as well, so I don't have to mess around too much with things. And I heard back from the seller from this as well. I found it didn't have option 2 installed in it when it's supposed to have that, and they've offered me a $50 refund, so that's fine. So that makes it, you know, a fairer deal. That's I'm happy with that now. Assuming of course it goes through, but let's see how we go. I mean, having faults I was kind of expecting, because it's, you know, that's what you get, but to not have the option which I stated it having, that's what the issue was. Now, notice how they leave these wires long so you can actually work on things. Let's move this back a bit. So I've got to get this PCB here out. Put this off. See which screws I've got to undo. I don't remember. Let me go right through to the main front. Yeah, I do. Right. So I pulled this front panel apart on my other unit previously. I had that button was just 40. And I did buy a spare front panel for it, thinking that I might have more issues with buttons. That screw's loose. And I had a check yesterday to see if the front panel was actually had the knob on it or not, with the pop, which isn't broken. But unfortunately that one's broken as well, so yeah, oh well. It's just a bit of a shame because I would have swapped the whole front panels around otherwise, but not much luck there. Yeah, is that it? Something's still holding that. That is separate. I believe that's... oh no, it's on the PCB. It is on the PCB. I've got to take this off as well. That's got to come off. This is going to be interesting. I don't have a tool to do that. It's got hicks on there. I haven't got any spanners in here though, that's a problem. Ah, interesting. Little fuse in there. I would have thought it would be soldered. It's not though. Okay. Right. Okay. Now I'll see how that goes. Hopefully this isn't shot. Here's the board. So it wasn't constructed quite the way I was expecting, but that's okay. So what it actually has, obviously that secures this barrel onto the front panel, and that's obviously, as you saw, screw through that into there, and it screws into the inside of that barrel, and that end of the fuse is supposed to be soldered into there, but it looks like it wasn't actually quite done. So maybe I need to look at that again. Yeah. Anyway, interesting design. I would have thought I'd have had to not have to desolder something to get that front panel off, but it seems that's the way it's been done. Right, so I need to get this pot here off. I need to figure out how to get that apart and what consequences there are to that. There's a header board there and there's two bolts here which hold that together. Ah, okay. I thought it'd be a plug connector, but it's not. It just sits in there. That's very interesting. I've never seen one of those before. Alright, so it's just got terminals each side which go right through to make up each side. Very interesting. Never seen that before. So I might give those a clean up too before I put it back together. Make some more space. Okay, well, it's a 1 meg ohm pot with 3 terminals directly on the back. I need to figure out what I can do to actually replace that. That's not going to be an easy job. I've not seen anything that looks like that. If I can get something which will fit through that hole, it might be okay. So I can get something to fit through there, then I could possibly mount it onto the front panel instead. That's a possibility. I can always drill a bigger hole through. Can't make the hole bigger on a PCB. That's not an option. So whatever I do has got to be very small. And that basically comes up flush with the front. So I probably do have enough depth in that gap there to mount it on the front panel if I need to, and just run a couple of wires through onto those terminals there. Let's go and see what I can find. Right, so I'm going to start putting this back together again. Now I've cleaned up these terminals on the back here for this adapter or connector used here, which is, so it's an interesting, I've never seen one of those before. Here's a close up of it. Get it in focus, there you go. So just rows of pins, and I've given that a clean up. I've got a little fiberglass brush here, if I can say it, fiberglass brush, and I'll just run that along the terminals very quickly, and on those as well, and on the mating side on here, on these terminals also. Just basically run up and down like that, and just takes any tarnishing off. And you don't do it too much, just get the worst of the tarnish off. And the same thing I did with all the connectors as well, for the actual interconnects, for the edge connectors. Now this part here, I should point this out, if you ever pull one of these apart, it only goes one way. Right, so if you look at the board layout here for these pins, you can see like the top row here is closest to me, closest to the screw. You have to make sure that the pin matches here. Alright, if you do it this way around, I mean that works too well. I can just suppose you can say it goes 2 rows around, but that way or that way. But if you flick it that way over, you'll be mismatching. It won't actually line up with the pads. So you have to be a bit careful about making sure that this side goes towards this board. Otherwise it won't line up with the pads. And that's a bad thing, because then it won't work anymore. So it's just a little detail I sort of point out. So as far as troubleshooting this goes, I haven't really found anything wrong. I've given the switches a clean and so on, but what I need to do is replace that pot, which is on the other board, which I'll show you in a second again. I haven't been able to find one exactly the same. I found some similar ones. The closest match I found was $40 for one. But, no. I'm sure I could find another way. So that's what I'm going to be doing. It's finding another way. So I'm actually surprised they weren't using like a header connector or something on here actually, instead of the arrangement they've used on here. You know, it would have been a little bit better, I suppose. Just want to make sure those pins kind of look like they're lining up. Hope you can see in there. Yeah, there we go. You can see the pads there on this side here. The pins going to them. Same deal there. So those line up fine. So the tricky thing is this pot here, you know, trying to get a replacement for this, because it's got these are 5mm apart in a triangular pattern. I did find something similar, so I've ordered some pots. So what I'm probably going to have to do is do it differently and change how it goes together. I don't think I've really got much choice in the matter. I think I'm going to have to mount a pot on the front panel and run wires down onto this board. I think that's what I'm going to have to do. So for the time being, I'm going to put it all back together again, and then I can just put it apart again when the parts turn up. I've got a pot, but it's not the right value. It's basically 1 mega ohm, and if you put the wrong value in, it'll affect the gate timing. I mean, a different value will work, but the gate timing won't be the same, and you might not be able to put it into the hold section, to the holding stage. So it makes it pretty much pointless. So I might as well just get a 1 meg pot and put it at that time. This makes a bit more sense. So that's what I'm going to do. So these things here are a little bit interesting, but these need to line up with each other as well. So it goes through from the back. Let's drop all these through so they line up. Okay, let's tighten these up a little bit. Like I said, I'm waiting for some tools to arrive. I've purchased some more little spanners and stuff like that, and little tools I can have in here in this little workshop, on my bench. Instead of, because obviously I've got tools, but they're not in this room. I keep them somewhere else, and when I want to do a little job, it's not really worth going all the way out there to go and get the bits. So I just prefer to do it this way. Might be a bit better for this actually. So just waiting for those to arrive, and once I do, I'll have a little set of spanners, and hopefully they go down this small. Actually, I'm not sure what size these are. Hopefully they go this small. Alright, so let's put this back in the unit. Unfortunately I can't really get on camera now. I've dropped the thing down a bit. I cleaned up the switches on the front panel and had a close look at that connector where this fuse thing goes in there, and it does look like it's actually like a socket. I think it is not supposed to be soldered, it's supposed to just push into it. So I think that's all fine. I don't think there's any issues there with that. So that's all fine. I do like the way they put these things together. I mean, they are pretty simple to work on. You know, you have to pull a few things apart, but you know, generally speaking, they're pretty easy. There's no real issues working on these things. They're very well designed. Just make sure that this keypad is not rubbing anywhere. Seems to be alright. Yep, seems fine. like I say, I'll pull this apart again when I go to get, well, once those parts arrive, I'll put it apart again and replace that pot. I'm gonna have to do a non-standard repair, I suppose you could say, but I can't really do much about that. It's just the way it is. It's a bit unfortunate, but yeah, it happens. Really need to get some kind of spanners which will fit on these slotted nuts. You know, a lot of these things. I'm just getting shot this there, but doesn't feel like it's going in very far. Like it's going in far enough to actually be touching. I'm a bit suspicious about that actually. Just want to make sure it's all sitting in there properly. It might not be sitting in properly. Right, I'm going to pause this camera and get some space sorted out. Alright, so this is the front panel from the HP frequency counter, the microwave one. Now it's got this broken knob on here which I was going to repair. Now I purchased two different types. This one here, which I was hoping would actually be right because it's got the right pin pattern on the back there. It's got like a triangular pattern which matches the one that's original. However, it's a bit shorter than I wanted, and if you look at like the effective depth of it from the back board, that is, you know, too short. It's not going to stick out the front, which is a bit of a shame. Even if I stand it out a little bit, it's still not enough. I mean, it needs to be sort of up here somewhere. I could possibly put those in standoffs, but then it just leaves me this tiny little shaft here, which is probably not good enough to even put a knob onto that. So that doesn't look like it's going to be suitable. The other option I had was this one here, which is a standard chassis mount one, and it's not ideal, but it'll work. And that's to mount this onto the front panel and just have some wire leads from here connected onto the back of this board. So I'll take that one out and just run leads to the pads, which are just here, probably over the back or something like that. Maybe put them on little connectors so so you can actually unplug it if you need to pull it apart. Something like that would make sense. Yeah, I mean, I need to figure out exactly how I'm going to do that connection. I could maybe come through the front of the board and plug it in there if there's enough depth. I mean, this has got a small enough height. See, it's going to fit in that gap just fine. So if you compare that to the other parts, you can see there's going to be there's definitely going to be a gap at the back of the control to the board, which is what I need to have. So it's looking like I need to use this one, which is a shame because I wanted to use this one, you know, to try and keep it as original as possible. But yeah, I don't think there's any way I can put like an extension shaft through or anything like that. I don't think that's going to be possible. I haven't got anything that small. This is a very small shaft size. Don't know what it was. I think it was 3mm instead of 6mm or something like that. So I think it's a 3mm shaft, if I remember rightly. So as I don't have a 3D printer, which would be really convenient right now, I can't use that one. I'm actually tempted to get a 3D printer, but anyway, yeah, so I'm gonna have to improvise and just take that pot there out. So I don't have to pull the boards apart to do this, so I'm gonna just do it. I've got my desoldering iron going, so it's just, see, we go. Actually, I might just put some fresh solder on to help it come off first. Always helps it a little bit. Right, this is going to be noisy. Come on, melt. I'm not convinced it's unsoldering very well. Let's have a closer look. This to me looks like it's going to be a pain. None of those have come off. Right, well, alternative technique it is. Got to be careful not to overheat it, that's the problem. My iron might be a bit too hot as well. Just slowly wiggle the thing out. Maybe once it's off the board a little bit, it'll be able to desolder properly the other way, but okay, it's out. Good. Right. Just looking at the traces where they go, because I'm constantly mindful that I've got a through hole there which I need to be careful of. Which doesn't look like it's got a great connection. So anyway, here's the original pot, and yeah. So yeah, that would have done the job. As you can see from the pin out there, it looks basically the same. But yeah, it's just too short. So I had to run for a little while till I could find anything. So this one it is. So that's definitely got plenty of clearance on that board. You can see there's definitely going to be a gap there. So I've mounted on the front panel, definitely going to be a big gap. So I tie the back of it touching anything, and it's run the wires around, and that's probably all I can really do. Now I'm guessing that that one there is the common on the pot. It's, ouch. So we'll find out. Maybe. This isn't actually measuring very well. Interesting. My meter's not liking this pot. Just do it this way. So I'm not touching anything. This is supposed to be 1 mega ohm pop, but I'm not getting anything in that direction. And that one I'm getting 323k. So that interests me somewhat. Maybe this pop was also faulty. Just going to try and turn it a little bit. Okay, showing 1 mega ohm there. So I'm definitely on the wiper one of those. Yeah, 1 mega ohm, that's as far as it's going to go. Stop there. So, okay. That's fine, I've got that pin out right. I'm not quite sure, I'm having trouble thinking about that. Should be easy, right, that's fine. So, I just need to hook this thing up. Let's drag the meter in. Well, the front panel in. It's part of the meter, it's still attached. So there's a hole for it. And it just goes through. It'll just go through there. I'm going to take that little spline off there, or should I put a little hole in the front panel for that spline, for that pin? Is it even in shot? Probably not. No, it's not. Here we go. Alright, so here's the hole there, and that's the part also. So I'm going to put that through there. Now, which way is Lag's face? Probably up or down will be fine. I think probably upwards would be better. Based on the spacing on the around the hole on the panel here, sort of space up and down. So, but there's more space upwards, so I'll go that way. Alright, but so it's obviously that little pin on there stop the pot from turning once it's in place. Now, I don't know if that's really going to be necessary. And I could drill a hole in the back of the plate to put that in. But, I mean, it's not going to have much stress on it anyway. Just the lock nut on itself will probably be good enough. I should have got enough thread going through to actually do it. I've got one turn of thread showing that side. Yeah, it's going to be close. It's only going to give me another 2 turns. So just enough for that to go on there, because it's quite a thick front panel. So it'll probably be good enough. I mean, I can always put a bit of adhesive on the back as well, just to help stop it from turning. So I think I'll probably just do that. That'd be right. I'm going to take that lump off there. There we go. Get it all the way through. Kind of jamming in there, so I was going to screw it in a bit. Okay, there we go. I've got enough thread on it, that's right. So, I mean, yes, I could put a knob on here, but the shaft itself is probably going to be fine. I don't really need a knob on here, do I? Oh, that is a bit big. This is the knob I had eyed up for it. As you can see, it's a lot shallower. So, and does have the pointer on it. It does probably need a pointer for that part there for the hold stage. Yeah, I'm going to have to cut this knob shaft down a bit to fit that on, so I shall have to figure out what I need to do there. Then I'll do the wiring part, so I'm going to stop there. Alright, so I've mounted the pot onto the front there. It's not done up yet, it's just roughly done. I've cut that shaft down with a pair of cutters, so the knob will go on the front like so. It's got a good clearance there, and so it all looks nice and close. It kind of matches the front, I suppose. It's good enough. I can always change the knob later on if I'm not happy with it, but yeah, did the job. Right, so I'm just going to lock this up into place. Now, these nuts are imperial, not metric, so this is a 10mm spanner and it's a little bit loose on there, but that's what I have. So let's just do this. I put a washer behind as well. Even though the pot didn't come with a washer, I put one in there so the front doesn't get scuffed up by it. Okay, so that should be tight enough. Now, where's the pot there? Let's go get this up enough so I can get the thing in the right place. Then turn it to a line up. Okay. Okay. Right. That's on. Now, go look at the wiring side. So, I've got options here about whether I put little headers in here with pin connectors or on the back. I definitely have to put wiring straight onto the actual pot and run some probably ribbon cable up. I'll use that. So I'm probably going to run it around and up the side, I expect, through this gap. There is space to come underneath as well. Could just fold it over and bring it underneath. That's also a possibility. Let's have a look. So yeah, probably have to go underneath because there's no real gap on the side there. Not where I want to put it anyway, so I'll bring it underneath and bring it up to here. That's fine. Get it back out again. Alright, so what I probably should have done is just face it downwards in that case. But it's getting a bit close to this other stuff, so I'm happier going upwards, and I'll just bring it around the cable. It's going to be better. Play it safe, I don't want to short anything out by accident. So I shall come back in a minute. Alright, so here's the ribbon cable, and I'll just cut a little piece off. It should be plenty long enough. And I'm going to solder it straight onto those pins on the pot there. And when I come to do the other side, I'll probably put some header pins or something on it. I'm not sure yet. I might solder straight on. It's not likely to have to come apart ever again, but you know, I want to future-proof a little bit if I can. There's a little bit of space behind, but not a huge amount, so it may dictate whether I can do it that way or not. So let's get these soldered on. My wire strippers are not currently in my lab, so I'm going to have to do it this way, but it's fine. It's like an aluminium wire as well, so it's not the best for soldering. It's not easy to get to take. Well, I think it's aluminium, I don't know, maybe it's just not very good, good wire, it's just not good. So, go on. Now I'm going to just hold these backwards like this, and then I'll still some heat shrink over it afterwards. Off. Barely. This one's probably better suited if I shrink enough. We'll try and find out. Yeah, it does the job alright. Use that one. Back in here, get that out. Right. So you've got plenty here. Right, I want to make sure plenty there. So there's actually a possibility of you can take the panel out and not have to disconnect it. So if I were to do pins there, I think I'll be pushing my luck a little bit as far as the height. Oh, that might be okay. So I'm mindful about that other side not being great either. I think I'll solder it straight on. Yeah, I'll just solder it straight on. Yeah, the other thing I've got to do is make sure I get the right way around. So the appropriate connections on the correct side. forgot to make note which way around I had that wire, so let's have a look at that. So white, which is fully clockwise, go to that one. So black to the center, white to that one. Okay. A little bit fiddly. Come on. Let's pass through just fine, so that's okay. Try and get in there and clean it up now. Where's the pad gone just now? Been asked a lot about these pads the past few days. A couple of people asked about these, where I've got them from, where they don't fall apart, that sort of thing. So these are from AliExpress, and they're basically makeup removal pads for nail polish. They're like a lint-free pad, and it stops them from shredding so much. They still do get some shredding if you've got something particularly sharp, but they don't just fall apart when you try and use them like a bit of tissue or something would, you know. So they work very well for this. Okay. So yeah, so plenty of slack on there. Right. So I want to leave a lot of slack on there too, obviously, because that's what I've done. And I'll probably cable tie something to tidy that up. Just means if somebody takes the front panel off again, they have to desolder it all to get the thing off. Could be me that has to do it, so probably cable tie it like that or something like that. The combination of toothbrush and pad means that you scrape away the residue and the pad then absorbs it. If you're just using a toothbrush, it just smears it all over the board. So that's why I do it using both like this, because then it goes into the pad, which is what you want. You want to get it off the board. Okay, done. Let's put this front panel back together. Yeah, you see that? I don't think. Oh, maybe a little bit. sure these aren't rubbing anywhere. Seems fine. Okay, so I'm just going to cable tie this to tidy that up. Figure out exactly which way I'm going to do it. I was doing all that. There's also this original red wire there, which I might just use as an anchor point. Hopefully having this long wire instead of the original pot going directly to the circuitry isn't going to be an issue. I doubt it will be, but you never know. Okay, let's put it back together. I'll come back. Right, so I've got it set up ready to try it now. I haven't actually tried it yet. I've got my signal generator turned on and ready to go. It's warming up. So let's see what happens. We still have a display at least. And the gate time's flashing okay. Looks like it's doing what it's supposed to be doing. Don't know. Maybe. Is it working right? I don't know. In fact, the hole is still flashing the gate, makes me wonder if it's actually working right. Not sure we'll have to see about that. Right, let's plug a signal in. And stick it on there. And there we go, we have a signal, so that's okay. So at least that's doing that. So I wonder if the hold will still work if I do that. So it looks like the hole's not working. So maybe the pot value isn't quite right. Even though it's 1 meg pot, and the one I took out was a 1 meg. Interesting. I wonder if I need to do some work on that. Because even at gate time, I don't know, it's looking okay there. It's flashing like it's supposed to flash there. It's okay. No, it just seems like the end of the hold isn't doing the hold. So maybe the pot value isn't quite right. Let's just change frequencies here. 500 megahertz should do it. There we go. Probably works exactly the same way. I don't think it actually does anything different. Yeah, it's like the hole doesn't hold. It certainly seems that way. But otherwise it's there's actually a delay about how quickly that changes, interestingly. It's not immediate, maybe it's after the hold time, I don't know. Anyway, or the sample time. Anyway, it still works. So I'll be making some progress with this thing. It's it's working better. There's a difference in sensitivity when you're on 1 megohm setting on this thing. So especially it actually dips in the centre of the range and then comes back up again. It's interesting enough. Right, so it's on 200 megahertz. But then my other unit, which I already purchased before this one, does exactly the same thing. So I don't think it's actually an issue there. It's just different sensitivity, unless they're both faulty in that way. I don't know, but that's also possible too, I suppose. But, anyway, so at least now I've got a working sample rate pot. I need to look at that hold function though, so I'm going to check that out. So I'll stop this for now. So here's an interesting bit of information. Now these pots, I bought 2 of them, right, 2 of each. So I've always got a spare. So this is the other one of the pair. It's rated 1 meg. So look on the side. There you go, 1 meg, right? And if I probe it across the ends, I measure 770k. That's not 1 meg. Right? So if I go from the center terminal, the wiper, to one of the sides, and then start at 0. Alright, that's fine. I'll wipe that around if I can get the thing to stay connected okay. And then again, you can see the maximum is 775, 774. So although it's marked as 1 meg pot, it actually isn't. It's a 770 meg, 770k pot, and that extra 200k is what it needs to go into hold mode. So this is from RS. Right, this is an RS components part, and it's crap. I'll have to look at changing suppliers. Right, so here's the diagram for the frequency counter. Now the input, that sample rate pot is just here, and you can see it's just a ground connection, and all it's doing is increasing the resistance to ground. So the electronic diagram I've got here is not great, but I've got a physical manual here which is perfect. So, but for sake of capturing it, I thought I'd just do it on screen. Right, so there's the pot, and it goes off to XA17 pin 2, which is page 183. So if I come over here, that should hopefully take me to it. It does too. Right, so let's come over here. Try and get this to scroll. Right. Right, so pin 2 is here, comes in, and all it's doing is adjusting the levels on this transistor here. So you've got a 1 meg resistor to 5 volt pulled up, and also through this transistor source here, and also with that variable resistor being a 1 meg as well, I mean it's probably just aiming to get a balance here. So it might be that that's the issue, is that it's not balanced. I'm thinking, well, if I change that resistor to 750, that would work. That's probably not the best way of doing it. No, I should really get the right pot for it, but I mean that was supposed to be the right pot, but the value's wrong. So I'm wondering if I should just put another series resistor on one of the pot legs to increase its value a little bit, to try and get it so it will do that hold stage. It will just mean the fastest sample rate won't be as fast as it's supposed to be, and that may not really be an issue. So might be able to do maybe a couple of resistors and try and do like some kind of bridge circuit there or something to actually work around that, but it's, for the sake of the pot being wrong, it's a bit of a pain. So anyway, I thought I'd show you that. So that's the actual circuitry is controlling this. Yep. Okay, so back on this drawing again. Now what I've done is, because of the lack of proper 1 mega ohm pot for the sample rate, even though it's supposed to be 1 mega ohm, it's labelled as 1 mega ohm, but it's only 770k. Right, and it means it won't go into the hold mode. Now, that sample rate pot comes here, and it pulls this line low. Now, so actually, the further clockwise it is, the more disconnected this is from 0 volts. So this voltage here goes up the further clockwise the pot is. Now, you'll see here R19's got a 1 mega ohm resistor in there, and I think 1 mega ohm there, 1 mega ohm on the pot, seems awfully coincidental to give you a 2.5 volt common through here if they're both fully open, right? So if you've got it fully clockwise, you should get 2.5 volts through here in theory. So what I thought, well, okay, well obviously if you ignore that transistor section there, obviously it's doing something too. I thought, right, I tried changing R19 to an 820K, so it's close to the value of the pot, which is 770 something, right? So it's closer, it's close enough at least, right? So I've done that. So that is then balancing the voltage between here and the pot, and now the hold function will work. So yeah, my theory there is correct. I've changed this to an 820, and that allows that pot to work. So if you get an issue where you can't get the right pot, but you know, and the value is off by, you know, as long as it's an 820K or something like, or around 800K, you can change this resistor at least. They've obviously got big values for a reason. I don't know what that reason is, but they've chosen big values. Now, I don't like to modify original values like this without a good reason. And the fact that both of these pots I've got the wrong value on compared to what they're supposed to be, it's like, well, do I order more pots and try again and just see what happens, or do I just change this resistor? So I've changed this resistor, and that's working just fine. So I'm happy with that. It's triggering just fine, and it's okay. So you know, obviously, if you can get the right pot, get the right one. This is a bit of a bodge, it's a bit of a workaround, but it's done the job. So now it's actually, the hold is working, and it's doing what it's supposed to do. So okay, so I thought I'd mention that and say that if you get stuck, there's a little workaround you can do if you ever come across that problem. Because I know there are a lot of these which have those knobs broken on the front, because they tend to be very fragile. A lot of the ones you see have got broken knobs on the front. The sample rate knob is just not there. Okay, right, that's that.